Hey guys, my name is Boris and I am currently studying computer engineering in my 5th bachelor semester at the Technical University of Berlin. And on this channel I want to talk about things that I've learned and might bring you value, general educational topics and perhaps a few lifestyle videos. Today we will take a look at the 5th semester of a computer engineering program. Now, this semester is the last semester which has mandatory courses, one of which is arguably the hardest one, your operating system practical course. But first, let's start with principles of measuring technology, or at least that's how I hope to translate it. So this is your last mandatory electrical engineering course, and to be honest, if you have had all the previous ones, this one won't be that hard. We'll start off with basic knowledge about statistics. I know you probably haven't had that yet, but there's always a first time. And the professors will take their time and explain those. For example, what the standard deviation is, the variance, what a probability distribution is, and so on. You won't really go into detail, but you will learn the fundamentals and things you need for the next big topic, measurement uncertainty. You see, if you make a measurement, there will always be a little error to the result, if you want it or not. Even if you perfectly diminish the systematical observational error, which you probably can't, there will still be random errors. To try and calculate the correct result, which means the result you have measured and the maximum error and the uncertainty, you'll have to go through a few steps. And that's why in the most cases you will have to do multiple measurements to have a more accurate representation of the result or the functionality of the system that you're measuring or the electrical component. Then you will learn about the stationary behavior of a system. For example, when a thermometer reaches the point where it actually records the actual temperature of the room or the medium. And you will look at the ideal characteristic curve and the actual real characteristic curve. And you'll see that there are errors. They don't overlap exactly. And you'll learn how to, which parameters you can tweak or settings you can tweak in the measurement or which algorithms you can use to shrink this error. For example, there is regression or interpolation. Next up is the dynamic behavior. So if we continue with the thermometer analogy or example, this is the behavior where the thermometer reads the temperature that rises or it warms up until it really reads the actual temperature of the surrounding or the medium. Here you will again take a look at the response curve of phase and amplitude. I told you in previous videos they were important. And how the system responds to a delta impulse and other parameters, for example, the rise time or the setting time. Next up is a big part of the course, the analog digital converter. You will go through the requirements, so what is needed to be able to convert a continuous voltage into a binary representation. And keywords for that are possibly the Shannon sampling theorem again and the sampling rate. Then you will talk about errors that occur when doing the conversion. For example, the quantification error, which you can't avoid, and the differential nonlinearity or the integral nonlinearity. Just throwing buzzwords around, huh? But nevertheless, then you'll take a look at a few methods, how the actual conversion works. For example, the parallel ADC or the successive approximation ADC and the dual slope integrator, and which amazing properties, for especially the last one, has or have. The main goal of this course is basically to build up a measuring chain. So the next component is a low-pass filter, which will be used as an aliasing filter. The next big part is power measurement. You will see that there are different types of power, such as reactive power, apparent power, and effective power. And the final topic are measuring bridges and measuring passive electrical components. Sounds perhaps again like a lot of content, but a lot of the things that you learn here are basically just things that you've already learned, just applied differently. Additionally, you will have lab visits each week where you will again go through all the important theory and get to write lab reports. Next up is a course about software engineering. So here you will learn how the process of planning and developing software is possibly done. Starting off with the planning of a software project, you will learn a few models here, how to plan it. Then you will go into the actual requirements engineering, so where you identify the requirements of a customer, so what they want the software to be able to do. And for that you will learn how to use UML and OCL. And this is a really big part of the course, and especially in the first midterm you would have in this course. So do some exercises and pay attention and you'll be good to go. After this big part, you will continue with the part where it's about actual implementation. Now what they focus on here is teaching you several different approaches and architectures to developing and planning out how the structure of the software should look like. For example, if it's a model view controller architecture or a repository-based architecture. And you will get to know things called design patterns. All of this is unfortunately pretty much learning by heart. And the goal here is just to teach you how to develop or plan or implement better code. Then you will get into correctness of a program. So does it actually do what it is supposed to do? And you will learn there about the Hoare calculus, or I don't know how to pronounce his name. Hoare? I don't know, he's a British guy. I think. Yeah, pretty sure he's British. Next up is code quality. Here you will learn a few metrics that are supposed to help you have a better and more well-written code. At about this time you will be assigned a homework where you have to implement some sort of game probably, or game logic in Java. And here you will have to account for a few of those metrics. This part at least is not really hard. You just have to do a lot of work since you have to write a lot of JUnit tests to have a full code coverage. And the last big topic is Haskell, a functional programming language. You will learn how to program with it, and you will have to implement possibly a bot in this language for your game as the second part of the homework assignment. At least that's what I had to do. I also talk about this assignment that I had to do with my group in my little life update video, and I will try to link it up in the info card. And the last topic is yet another programming language, or rather concept again, the concept of logical programming in the language Prolog. Here the base of a language are facts and rules that you define, and then there are logical terms which infer data based on the facts and the rules. And the process of proving a request, or if it is correct given the facts and the rules that you have implemented, is done through unification and resolution. Now for some people this course is fairly simple, since you don't really have to learn that complicated topics. You just have to exercise in OCL and UML and in Haskell, and then you basically just have to learn a lot of things by heart, which is not my favorite thing to do. So let's come to a course where you have to work a lot but not learn anything by heart. The Operating System Practical course. Now I have to say this from the beginning. This course is the hardest course of your entire bachelor program, arguably, considering the time you have to put in to finish your assignments. But with that said, this is, in my opinion, really one of the most interesting or even the coolest course in the entire program. you really learn a lot. Not perhaps in terms of a lot of theoretical content, but rather how an engineer or a software developer really works, namely with Google. If this program or any computer science program teaches you one thing, then it's that Google is your very best friend. So there's not that much to talk content-wise, especially since this course is changing basically every semester due to students whining that it's too much content, especially considering that this course only gives 6 credits, which is true, but again, it's totally worth it. But you will, for example, start by learning how to implement your own printf, and with that how to communicate directly to a driver, and in this case the UART driver. Then you will activate interrupts and exceptions and learn how to work with those. After that you will get to the concept of threads and multitasking, and how to basically implement your own threads and the respective threads control blocks, and how to switch between threads based on a scheduler that you have to implement yourself. Now, this can be a bit confusing, but it's really interesting. And then you will expand on that with processes and implement those. Then you will learn how to make your operating system securer by splitting the OS in kernel and user space, where the user can only communicate to the kernel, or rather use kernel functionalities by using system calls. To split it up even more, you will go into the memory layout and split up certain blocks and then assign those blocks to certain parts of the operating system. For example, the interrupt stacks, the kernel code, the user codes, the user stacks, and so on. And finally, you will activate the MMU. So the memory is not only physically split up, you will also be able to assign writes to the certain memory blocks. For example, the kernel code won't be able to be accessed through a user application. And with the MMU, the memory gets virtualized. All this might sound familiar, but implementing it yourself is a whole nother thing. You really start from scratch. You won't have any given files. You'll really start your own project from nothing. It really is amazing, and you really get to appreciate the engineering that goes into developing an operating system. If macOS or Windows or Linux, it really is impressive. And with those last mandatory courses, I would finish this series here, since the rest is free choice and it can go in several directions where I don't know anything about. If you haven't seen my other videos on this series, I will link up the playlist about there, where I go through all the previous semesters of a computer engineering program, specifically here at the Technical University of Berlin. And with that said, I really hope you enjoyed this video and found it somewhat helpful and interesting. And thank you very much for watching. See you guys in the next one. Bye!